Right, good morning. Okay. Again, you're not going to see my face today. Tough luck. Sorry, you'll have to wait. Go back and watch the old videos if you're desperate, I suppose. Questions on the screen for you now. Have a go at them now if you would like to. Pause the video, or you can have a go with me. Okay. I tell you what, I say the same thing every day, and every day I don't know how I'm going to say it. It always, why don't you pause the video? I should do a script myself. Okay, round 24,563 to the nearest 10,000. So the 2 is in the 10,000s column. 2, 4, 5, 6, 3. Yep, that one. So it's this one. So that's the digit that they're asking about, the 10,000. So same as always, you look for the column to the right. If it's the digit is 5 and above, you round up. If it's 4 and below, you round down. It's 4, so it rounds down. So it becomes 20,000. Okay, not 2. 20,000. Okay. Next three numbers, 38.7, 38.8, 38.9. Ooh, so it's going up in 0.1s or tenths. Okay, so 38.9 add a tenth would be 39. All right. Sometimes I find it easier. Imagine that decimal point isn't there. So you've got 387, 388, 389, and it's going up in ones. Well, the next one's going to be 390. Okay, and then it's going to be 391, and so on and so on. So it's 39, or 39.0 if you want, and then 39.1, 39.2. Oops. Okay, it's again all about establishing the rule and then applying that rule to the order, I suppose, sequence. Oh, I hate these ones. Right, order smallest to highest. Struggling to read them. I said those out funny. Right, smallest to highest is first of all worth remembering. The amount of USC, do highest to smallest, because you've forgotten which way around, is criminal. So I'm assuming that the commas are the separation of numbers. So you've got 3486, 3,486, 483, 34,000 and something, 43,000 and something, 4,000 and something. Well, obviously the smallest one there is 438. Okay, then I'm going to cross that out. And then there was a 3,000 somewhere. 3486. Get rid of that. Then it's 4348. This is quite an easy question, actually. 34,862. And then finally 43,862. Just get rid of that comma, because that'll confuse you. Normally, what I would say is that you look at the place value column to the left, and if they match, then you keep working from the left. So you'd start here. If they match, then you go here. If they match, then you go here. If they match, then you go here, and so on and so on. But there's been no overlap there. They've just used the same digits all in a different order, so it's a really straightforward question when you unpicked it, actually. 560 divided by 5. Okay. So, two ways that you could do this. You could partition. Well, there's a couple of ways, actually. You could use bus stop method, obviously. I'm trying to stay away from the formal methods where I can spot shorter methods. You could partition, so you could do 500, and then you could do 60. That would work very easily. 500 divided by 5 is 100. 60 divided by 5 is 12. So you've got your answer there already. The initial thing I spotted, and I think this way is actually easier, is dividing by 5 is the same as half of dividing by 10. So if you were to do 560 divided by 10, you'd get to 56. If you take your 56 and you multiply it by 2, you get 112. And doing that is the same as dividing by 5. So that's how I'd have done it, but I actually think spending 5 seconds and looking at the question, that was probably an easier way. But the answer is 112. And again, you could have used bus stop method for that. You'd have got the same answer, but it might just have taken you a little bit longer. Okay, a lot of maths is about spotting those shortcuts, those easy routes. A lot of it will rely on stuff that you already know as well. So if you're using bus stop method for a question like that, you already know what 500 divided by 5 is. Okay, you're sort of wasting your time with all the layout and with all the carrying and so on and so on. It doesn't need it. 2/14 add 3/7. Obviously, they can't interact, they're different denominators, so we need to make sure that they're the same. I could change the 14th into 7th, but normally, or you might get something that can't divide very well, so you normally choose the smaller digit denominator, chosen my language carefully there. So choose the smaller digit denominator and multiply it so it becomes the larger digit. The reason that I'm choosing it carefully is that this is actually worth less than this. If you were to have a cake and split it into 14 pieces and you had one piece, and then you bought another cake, split it into 7 pieces and had one piece, this piece would be bigger than this piece. So this 14th is worth less. Anyway, so we're going to put them both over 14. So this one can just stay the same. It's 2 over 14. 7 times 2 is 14. So 3 times 2 is 6. And then what do I need to do? Add them. 6 and 2 is 8 over 14. Okay, or converting it back to sevenths, divide them both by 2 is 4 sevenths. Okay, either of those would be correct. 8 14ths or 4 sevenths. If it were to say simplify in the question, or give your answer over sevenths or whatever, then obviously you'd have to do it, but it doesn't specify what it wants me to do, so leaving it over 14ths is fine. 78.894 times 100. 78.894. Did I say over 100? I meant times 100. So let's pick a place value column. So let's pick this one. So we're going to go... So that 8 is going to become my tens. 8 tenths is going to become 8 tenths. Because you're multiplying by 100, everything moves 2 place value columns to the left. So let's start with that. So that will go there. So you're going to have 8 there and 7 there. And then 9 and then 4. Let me just check that. So the 4, yeah, the 9, yeah, and so on and so on. So that's right, 7,889.4. Okay. Confused myself on that one. Round 45.34 to one decimal place. Had this yesterday. It's the same wording. It's different wording. It's the same method as question 1. This is your one decimal place. So you're going to look one place value come to the right. It's a 4, round down, 45.3. Okay. Multiply 13 by 17. I'm not going to use a formal written method for this one. I'm going to use a bit of a shortcut. So let's do 17 times 10 equals 170. 17 times 3, I don't know. But I can split that up. 17 times 3. 10 times 3 is 30. 21, so it's 51. So 17 times 3 equals 51. Add them together, it should be 221. Okay. Again, if you wanted to set it out like this, and you wanted to do 7 times 3 is 21, 10 times, and so on and so on, it's fine. But that's not, for me, that's not my preferred method. I find it's very easy to make mistakes on things like that. By doing stuff like this, I just feel I have a bit more control over the question. And questions like that are nice and easy to apply it to anyway. 17 times 3 isn't that hard to work out at the end of the day, is it? Which are composite numbers. Now we're going to leave that one for now because we haven't done composite numbers as of yet. So I'm going to leave that one and then I'll come back to it at another point. Okay, so we're going to go to the bottom one, find factor pairs of 48. So, factor pairs of 48. So put it up there. Again, factor pairs, you put them into the pairs first of all. So you've got 1, 48, 2, and 24. It's 3, 1? It is, but I don't know what it goes with. 3 and 8, 6, 16? Just check that. 16 times 3 is 48, 30, 18. Yeah, that's fine. 4 is, I think it's 12. 12 times 4, yeah. 4 and 12. 5 doesn't, 6. 6. Yeah, it does. 8. 8 times 6. Just have to check that one again. I should know that one, shouldn't I? 6 times 6 is 36. 42, 48, yeah, that's fine. I'd rather get it right than look stupid. 6 times 8, 7 doesn't, and 8 does, but obviously we've already got it, so we reached the tipping point. Okay. Right, as usual, I will put a challenge question up for you to have a go at now. Pause the video, have a go at it yourself, and then I will come back with my lovely voice and explain it to you. So, you've had obviously the chance to pause the video now if you wanted to. What it's asking us to do is use the digit cards to find what A could be. Okay, so we're going to fill in this calculation and spot where we need A to go. So it's an addition. So first of all, we've got a bit of an issue there because it's saying 3 add something is 9. Well, it doesn't say, it doesn't say 3 add something is 9, it says 3 add something is 2. What I'm trying to say is 9 needs to go here. 9 needs to go there, but we haven't got 9 as a digit card. So there's a good chance that that A is 9 and we've worked it out already. So let's go through the calculation, assuming that A is 9, and see if we get it all right. And if we do, we've worked it out really quick. If we don't, then we're back to the drawing board. Okay, so 3 add 9 would be 12. So what they're saying is there's a carry here, but they're not showing you. Okay, so 3, how do I want to do it, like that? Yeah. Add, and then place values, really important here. Box, box, box. Okay. And that should equal 2, 7, 4, 3, 5. Right. So 3 add something, I think that's 9. So let's assume it's 3 add 9 is 12, so we get there. So 7 add 1, 1 add something, add something. So we've got a choice of 0, 5 or 4. So let's try 5. 5, 6, 7. Yeah, so that's 5. Okay. 4 add something is 4. Well, that's 0. So this one here, 7 and 6 is 13. Oh, what a donut. What a donut. I've crossed the 4 out and I've not used it. Crossed the 5 out, right. Oh, I nearly threw myself off by my own sheer stupidity there. Right. So, I think that's 9. I've used that, and I've used that. You donut. Right. So 7 add 6 is 13. So we're going to carry the 1 over. Something add 1 is 5, and we've got 1 left. It's 4. Okay, threw myself there because I've used the 5 here, and then crossed the 4 out instead. Over there, like a fool. So I was right. Straight away, A must be 9, has to be, because everything else fits and I get the answer. So A must be 9, but they've made it lovely and easy, and it was the very first thing I had to work out. So there you go, that's your answer. Value of A equals 9. Okay, see you tomorrow.